Hello everyone. Today I will discuss with you all the important linear data structure which are popularly in use in the real life. There are mainly four popular data structures that are linear in nature and are used in the daily life and also in real-time application and even in software development, system design, machine learning and newest technologies. These are really very relevant. So now, first of all comes our arrays. It is the simplest data structure. But before that, I would like to state the names. As most of you will know, the these are the linear data structure, and data structure are of two types: linear and non-linear. Okay. So and there are some data structure which can act as both linear and non-linear, like hash tables. So now, the popular linear data structures are stack, LIFO, which follows the LIFO principle, queue, that follows the FIFO principle, linked list, and there are basically four types of linked list, and even more advancement or modifications of these are available. These are basically four types, and nowadays some advanced version of linked list is available, something called skip list. So that is a combination of concept of linked list and trees. So singly linked list, doubly linked list, CLL for circular linked list, and CDLL means circular doubly linked list. And last of all, simplest arrays, because I have started it already. And now I'll go back to the arrays. So I had already told that it is the simplest and it is the easiest to implement among all the DAs, and based on it, the another data structure or data type, you can say data type, actually string, based on the arrays, it is available in C, and in other languages the string keyword is used to define Java, C programming. Character array is used, or character pointer. Using malloc we can create the strings, and in C++, the small string STL container is used actually for storing the string, and in Java, capital S only, and they are all are small. String is written as string, all are small basically, and in Java, the string is written as capital S and rest are small. So now, this is a basic, and in Python it is represented as st and r in Python. So here the elements are stored in contiguous fashions or the consecutive fashion, and in even in consecutive memory locations. If it is the memory, you all of you can see, I hope. If this is the memory, this is the memory, the computer memory, but actually this cannot be represented like this. But I am showing, if it is a memory or a fraction or a fragment of memory, and the memory will be partitioned into this portions or into these locations, because the memory consists of multiple locations. So the array, what array basically does, it stores the elements in these locations, contiguous locations one by one, or even we can skip and store. Okay, that is possible. There is nothing to be sequentially. It can be done randomly. First we can insert the first element, then we can insert the third, then we can insert the second. There is no such restriction. But in linked list, before creating the second element, we cannot proceed to the third. After creating the first, we need to go to second and then third. So there is a sequential access type of principle working over there. But here it's pretty simple. So this is the basic concept of it. Now, because today I'm not going to the details, and the basic and the simplest and the fastest real life example of array is that if in a queue or in a line within the assembly, in the assembly, if no teacher is there and no supervision is there. In absence of supervision, the children may break the line or even enter in the haphazard order in the line. They may not enter one by one or one after the another. And while after the assembly ends, if the teacher is not present, the students may break the line. So that is like the concept of array. One student might leave the line, uh, assembly line actually, not each and every line or queue. One student can leave this line first, okay, and after that it may happen not actually at the end, at the middle of the assembly. If a student due to some emergency might have to go, then what will happen? The next guy who is standing exactly next to him or after him, he will occupy his position after he leaves. So this does not follow the any principle like the queue follows. So you will get it if I describe the queue. And in the stack, it is very basic because it follows the last in first out. That means the element which is pushed or which is inserted at the last will come out first. You can compare it like an auto. An auto means auto which is a vehicle, and it is closed at one end. It is closed at one end. Okay, it is a window, window side of a auto, and this is the middle position. You can hope and four-person can see it in that auto, and this end is open. You can take this end as closed, and this end is open, semi-open and semi-closed type, open closed. So you can take the top. This is the open end, and if the passenger who will sit at the last, who will come out at the first. So this is the basically analogy with respect to the real life, which exactly correlate or relate to the stack. So now I will next say that it also is used in a programming and even evaluating string expressions, evaluating expressions, arithmetic expression, logical expression. Even expression is given as suppose result equals to a plus b into d raised to the power say f, and those maybe numerical values, maybe floating point values. So this is the basic concept. And even if you want to check a string is palindrome or you want to reverse a string, you can use this stack. You can see that if a string characters, suppose I have a b c d, so if I insert one by one, so a will come at the last, and when we will just pop back or pop out the elements or just remove one by one, the d will be at the top, so it will come out at first, then d, c, b and a, so it will be reversed just. So this is the another application, and many more application are there like checking balanced parentheses and so on and so forth. And in a queue, the basic concept you can correlate that this is very much similar to array, but in it the restrictions are there. There are two ends. That is the first of all front end and the rear end. So the through the front end, the deletion operation takes place. That elements are removed from this end, and at the rear end, the elements are inserted one by one. And when there are the queue is empty, then the front is equal to the rear and equals to say to minus 1. After one element is inserted, front is incremented, and just rear also incremented. After the rear is incremented until elements are inserted and front remains constant. If one element is deleted from this position, then front is also incremented. So basically the number of elements you can store is dictionary, so the space is wasted. So this is one of the disadvantage of the, and everyone, almost everyone who are in CS domain knows that it is used in fast come fast serve CPU scheduling algorithm, and also in depth first search traversal of the graphs. Suppose you have any directed graph specifically, even you can have the undirected graph, but directed graph it is more helpful. In directed graph, if you perform the depth first search, then the queue is very helpful to find the adjacent neighbors of the nodes one by one until you we uh, reach the last node, and after that again we backtrack. So where you use DFS, so there is the involvement of backtracking algorithm until we cannot find another a new node. We just go on visiting and until we reach a node, and all the nodes in that path is visited with backtrack and try to find out a new path, and also try to find out the new nodes so that we can visualize easily while studying graphs. Now in a linked list, it's also a little bit complicated linear data structure that uses the sequential storage principle. Why? And while creating and connecting them, we need dynamic memory allocation. Basically, it is similar to using a class in Java or C++, and in C we need a structure to form this kind of data structure. So first of all, we had a head pointer which stores the address of the first node of the linked list, and after the first node is being created, the head points to the first node, and if head is null, that means the linked list is empty. So and after the creation of the first node, when the second node is created, the address of the second node is stored in the next field of the first node. Actually, linked list consists of multiple nodes, and a node consists two fields. There is data field and the next field or the address field. So this contains the address of the next node. So now, and for the last node, the address field is null or it points to nothing. So you can just basically multiple symbols you can use over here, like see single arrow or single slash, backslash, front slash, both together, cross, and even earthing symbol. So this is a basic thing, and this is the basic things to be noted. And a kth node, here you put first, if it is passed, then k plus 1 is second, first point to second, second node point to third, and this is happens with the linked list, and similarly, and you can use this to implement the nonlinear data structure like trees basically, and graphs also, because trees are special types of graphs. And actually in graph representation, there are two kinds of representation. One is adjacency matrix and another is adjacency list. In adjacency list, this linked list and also adjacency set is there, but basically those two are very important: adjacency matrix and adjacency list. And even in discrete mathematics, incident matrix is there, which correlates the vertex to the edges. And in adjacency matrix, what happens, the vertices are correlated to vertices. If I want to give that example, I can show you. It is very simple, pretty simple. If we have a graph like this, it is a triangular type of graph or a triangular shaped graph, and you have three nodes basically here. So if this is vertex 1 v1, if this is vertex 2 v2, and if this is vertex 3 v3, and this is the graph G. So these are the edges 1, 2, and 3. Three edges are there, and it is an undirected graph. It's an undirected graph. So three edges are there, and this is an undirected graph. So basically, you can see that if we want to represent this in form of adjacency matrix, then we need a 3 cross 3 matrix over here. It is also always be a square matrix. So it's very and pretty simple that first we need to write a matrix, and we write here v1, v2, and v3, and three edges are there, we can number it here, but no need of that because adjacency matrix we are doing over there. Again v1, v2, and v3. And in case of simple graph, as we all of us mostly knows that in simple graph there are no loops, that no self loops are there, or no parallel edges are there. Suppose this to this not there, so no self loops and no parallel is a simple graph. So always the principal diagonal or the leading diagonal elements will be 0. That is v1 is not connected to v1, v2 is not connected to itself, and v3 is also not connected to itself. So this leading diagonal will be 0. And we can see it is an unrighted graph. So that implies that v1 is connected to v2 and even v2 is connected to v1. Bidirectional type of connection is there. It is connected v21 implies v12. But in undirected graph, we cannot tell that one v12. Actually, v12 is not better. It does not justify. If I tell like this, e12 implies e221. That means if there is an edge from 1 to 2, ordered pair type of concept, ordered and unordered pair, then there is also an edge from 2 to vertex 2 to vertex 1. So this is a important property of undirected graphs. But in directed graphs, what happens? This will become invalid. So here it is a symmetric matrix. So similar. So we can see that 1, 1, 1. That is symmetric about the leading diagonal. That is a symmetric matrix. If we compute the upper triangular and lower triangular matrix, it will be symmetrical or superimposable or overlapped with one another. And if we interchange the columns and rows, we'll get the same matrix. A equals to A transpose. That is the important property of symmetric matrix. So up to this, I hope it is clear. And in adjacency list, what happens? I can show you all, my friends. So you can see that basically the vertices are there, and corresponding to the vertex, whose vertices are connected in order that are represented using this matrix, and that is the linked list representation. So here it is very significant. So in this lecture, I hope this much is sufficient, and if some mistake has been committed unknowingly by me, so please forgive me, friends. And I hope that you will enjoy such type of video lectures in the future and get benefited from it. So thank you all.